Welcome to the Digit Concepts portion of the Tools Tour. My name is Matthew Lefevre. I'm going to be talking to you today about several techniques we use for laser IC decapsulation. Just a brief introduction to our company. Digit Concept is a provider of tools for failure analysis with an emphasis on decapsulation. So we distribute worldwide control laser systems, laser decapsulation system, the FA-LIT, which we see here. So I'm going to talk to you about some new advances for this tool in 2014. So in classic laser decapsulation, the idea is that we're taking an infrared laser at 1064 nanometer wavelength, and we're going to scan that across a sample with the molding compound. And we're going to remove the molding compound and make a cavity, but we have good selectivity between the wires and the molding compounds, but we cannot discriminate with the die. So we're going to have to stop before we reach the die and finish up with either an acid or plasma decapsulation. So what I'm going to discuss now is the concept of what we call ICO, which is IC optimized laser parameters. So if we look at a typical laser pulse, we have two regimes in it. The first regime is a very high peak power, which is more like a thermal shock wave. And this is going to remove the filler balls, because what we have in the molding compounds is a heterogeneous material, which is a plastic holding together large silica filler balls. The peak power is going to remove the filler balls, and then the tail that we have coming out here is actually used to heat up the plastic material. And what we can do with the ICO option of the laser is actually play around with the different laser modes to optimize the balance between the peak power and the heating up in order to efficiently remove the filler balls without damaging the wires that we're trying to protect. Okay, so just to give you a few case examples, on the left, or on the top side, we see the results with a non-ICO laser from a competitor. So on the left-hand side is the molding compound after a certain number of repetitions with the laser. And the dark spots you see is actually where the filler material has not been removed during the laser ablation system. So we start getting a very uneven surface. And after a while, the ablation will sort of self-arrest. On the bottom is with ICO. So due to optimization of the parameters with our special waveforms, we've been able to evenly remove all the molding compound. And on the right-hand side, again on the top, we can see the type of damage a laser can do to the wires if the parameters have not been optimized. On the bottom, we see with the ICO. Okay, another new option in 2014 that we have with the FA-LIT laser is TempGuard. And this allows us to have a blast of cool air over the piece as we're ablating with the laser. And this allows us to control the temperature. And we actually have a heat gun too that allows us to measure the temperature as we're doing the ablation to make sure that we don't go too high in temperature. So we can see a difference on the left without the temperature guard and on the right with the temp guard. We're able to better control the heat and thus avoid damage on the wires. Okay. Another thing that's becoming more and more important that we're seeing is the use of gel encapsulants on especially high-powered devices. These are clear gels which are there for dielectric purposes and also very low stress on the wires. The problems with these is that with traditional laser we are not able to remove them because the gel itself is transparent to the laser wavelength. So what we're going to do is we have a second laser that we can implement into the tool, which is a longer wavelength laser, which it does allow us to remove the gel encapsulant without damaging the die itself. So in this case, for the gel laser, we're able to go down to the die itself, which we couldn't do for a typical molding compound, without damage to the die. And so we don't need to use any chemicals or plasma after an opening. Thank you very much for your attention. You're welcome to come by and visit us at booth 221 to see the tool and give a live demonstration if you want. Thank you very much.